G'day everyone. How nice it is to see so many of you join us for the 2022 Angus Connect event. And this particular event today is going to be all about the upcoming TACE enhancements. So thanks very much for joining me. My name's Jake Phillips. I'm the Extension Manager at Angus Australia. It gives me a great pleasure to also introduce your co-host for this afternoon, Jen Peart from Central Queensland. How are you, Jen?
I'm great. Thanks, Jake. How are you?
Very well, thank you. Very well. So there's plenty to get through this afternoon. So I might suggest that we will get stuck into it. But just a little bit of housekeeping to start with. Just wanted to thank our partners who you'll hear about throughout this presentation sincerely, but also a lot of the other staff at Angus Australia who have helped us get to this point with the enhancements, but also particularly with this event today. But most of all, we'd certainly like to thank our members for your ongoing commitment to the programs that we conduct, and also to the breed more generally across Australia and New Zealand. So thanks a lot. And we would also just like to acknowledge that we are sending our thoughts to those that are flood affected today and in recent times. And we hope that things do improve for you quickly. And certainly if there's anything that we can do from your dealings with Angus Australia point of view, please do not hesitate to reach out. Just a point around questions today. We will be using the chat box, which is located in your Zoom controls there. And so if you do have any questions throughout the presentation, please put them in there. Jen will be doing a great job of monitoring that chat. We will be pausing at 2 stages through the presentation to be able to answer those questions and have a discussion with a couple of the presenters. So we do certainly look forward to that. So if you've got any questions, please put them into the chat box. I do need to let you know that we are recording this presentation today, and this will be available to all of our members and others at a point in time in the near future, hopefully by the end of this week. But we will also have most of the content that you'll see today available to you in the short little while. So just need to let you know we're recording. Of course, if you've got any further contact information that you would like more points of clarification, please don't hesitate to reach out and get in contact with a member of Angus Australia. Today's team, we are welcoming Christian Duff, the General Manager of Genetic Improvement, to the team today to give us a bit of an oversight of what's been happening in genetic improvement, particularly around TACE enhancements. And we'll hear from Christian in a little while. You're there, Christian, at the moment. I'd also like to welcome Andrew Byrne, the Genetic Evaluation Manager as well. And both of them will be available for questions throughout the presentation. G'day, guys. How are you?
Going well today, Jake. Look forward to this presentation and answering some questions.
Very good. Thanks for making the time, and we certainly look forward to hearing from you throughout the presentation. We also just would like to thank and Dr. Steve Miller and Dr. Andrew Swan aren't joining us live today, but we certainly have some very valuable contributions in today's presentation. And Christian and Andrew will obviously reference the sheer amount of work that they have both done and their supporting staff to get us to this point. And we look forward to their contribution to the program. Just the agenda that we'll be rolling through over the next little while. We're about to get stuck into the first enhancements, which is arguably one of the more comprehensive, and will certainly take a little bit of time to work through. We'll then pause for discussion and questions. We'll then move on to enhancements 2 to 7 and have some further discussion and questions at the end of those enhancements. And then I'll bring it to a conclusion in approximately an hour and a half's time. So we might get stuck into the first of the enhancements.
G'day, I'm Christian Duff, Angus Australia's General Manager for Genetic Improvement. We're pleased to deliver this Angus Connect event outlining a number of significant enhancements that will shortly be made to the calculation of estimated breeding values, EBVs, for Angus cattle in Australia and New Zealand. The enhancements form part of the annual updates that Angus Australia makes to the TransTasman Angus Cattle Evaluation, with the enhancements scheduled for implementation in the December 2022 analysis. This analysis is usually published by the 30th of November. The annual updates that are made to the TransTasman Angus Cattle Evaluation ensure that the EBVs published for Angus animals continue to be the best possible estimate of an animal's breeding value, maximising the genetic improvement opportunities in Angus breeding programs. It's very important that we acknowledge that the enhancements are made possible through strong, long-term collaboration with R&D partners and service delivery partners, particularly the Animal and Genetics Breeding Unit, or AGBU, the Agricultural Business Research Institute, or ABRI, Angus Genetics Incorporated, AGI, which is a subsidiary of the American Angus Association, and CSIRO, Australia's National Science Agency. We trust that you'll find the following presentations interesting and informative. They'll be delivered both by Angus Australian personnel and our R&D partners, particularly scientists from AGBU.
Hello, I'm Steve Miller, Director here at the Animal Genetics and Breeding Unit here in Armidale on the UNE campus. And today we're going to talk about some changes coming up for the TACE evaluation. And as a breeder, you might be asking, well, why is the TACE evaluation changing? And what's the benefits for you? And the changes coming up are to do with changes in the genetic parameters and the adjustment factors that go into the evaluation. And the reason that these things should change is because over time, the cattle that you're breeding change. When you think about your making selection progress, and the cattle today are bigger, faster growing with more marbling, and all those reasons are some of the reasons behind why those adjustment factors and parameters and things behind the evaluation need to change. Also, there's some traits that are relatively new in Angus, and now there's a lot more data than there was available when the parameters were originally estimated for those traits. So now with more data, we should try and do a better job, and we can be more accurate in estimating those parameters. So a good example of that is retail beef yield. And today with this most recent analysis, there's close to twice as many records, for example, on retail beef yield. So we can do a better job of estimating those parameters. So the parameters we're talking about are heritabilities, genetic correlations, adjustment factors. What's heritability? How much of the variation from animal to animal is actually due to genetics? So, how much can we influence the progeny due to parent selection? Genetic correlations between traits. The TACE evaluation, the core of that is it's a very large matrix of all the traits together. And, what's the genetic correlation between each of the traits is really important, because we're often trying to predict an important outcome trait, say carcass marbling, but you've got a scan trait on an animal, and it's the genetic correlation between those that matters. And finally, adjustment factors. Our traits are typically at a constant age or a constant weight, and we need the factors, because all the animals aren't measured at a constant age or constant weight, so we need to accurately adjust from one age or one weight to another. So I look at your genetic evaluation, and the analogy I like to use is back to tuning a car. So today you've got a genetic evaluation that's running, and it's got those parameters are in there as they are today. That evaluation would still run, and you could continue with the same evaluation for time going forward, but it wouldn't be the right thing to do, because it wouldn't be as accurate as it could be. And when I think about a car engine, there's a number of systems that come together, so that engine runs optimally, basically. And people today, aren't that familiar with tuning a car engine, because with electronic fuel injection and electronic ignitions and things, these things really don't change over time. In the old days, in the 1970s and 60s, those things actually, as the engine wore, the timing changed. And so you needed to constantly kind of tune the engine. And you would go in and you would adjust the spark plug gaps, and you would adjust the timing of the engine, when that spark occurred relative to the top dead center on where the piston sits on the engine. And you would adjust the fuel air mixture, and you go into the carburetor and you adjust the low speed mixture and the high speed mixture. And you would do this on a regular basis to keep the engine running in an optimal way. You wouldn't have to do that. You could not tune up your engine and it would still go down the road, but it just wouldn't be as optimal as it could be in terms of power and in terms of efficiency. It's the same with the genetic evaluation. You know, we could just leave it as is, but we know it wouldn't be as accurate as it could be. And it's all about accuracy, because we want the EBVs that you see, that you make your decisions on and to breed your cattle, you want them to be as accurate as they can be, so that you've got confidence as breeders to put that selection pressure and confidently sell and buy your animals with the most accurate information. So this piece of work has actually been a considerable body of work over a number of months, and it's been done by the team here in the AgBoo building. And I think Angus breeders are quite fortunate, because the team here actually has a lot of experience in doing this type of thing, and they've done it many times for different breeds and different species even. And around the world, that expertise isn't that common. And so we're really fortunate here in Australia to have the team that we do, basically being the technicians behind your genetic evaluation. Just like you wouldn't necessarily want to turn tuning your engine over to just any mechanic in the shop. You want to have the best mechanic that you can, a person that's got the experience, that knows how these things run. And that's exactly what you have in terms of the recent updates to the genetic evaluation here for Angus. And I'll call out one. It's been a team effort, but certainly the one scientist has put in most of the work is Dr. Gilbert J. Rubin, who's been here at AgBoo for a long time. And he's got a lot of experience with the data and with the models. And so that's really been months of large data sets on large computers, and all that's been funded through Meat and Livestock Australia, which is great for Angus breeders. So I'd like to wrap it up with, you will see changes in the EBVs, but to keep in mind that there's a reason behind it, and that is the changes that have been made. You can consider it like ongoing maintenance, but the evaluations that you have today are as accurate as they can be given the current data.
Just was remiss of being a little bit trigger happy on the technology this afternoon, everyone. Not to introduce Steve properly, Dr. Steve Miller, and we do thank Steve for his contribution in that forward for this presentation, has been the director of AgBoo since September 2021. And prior to joining AgBoo, Steve was the director of research at AGI, which is Angus Genetics Incorporated in St. Joseph, Missouri in the US. Steve, you may have heard about or from previously, and Steve has worked in livestock genetics and research across Australia, New Zealand, Canada, and the US for a very long time, and we're very fortunate to have the contribution and the knowledge of Steve to contribute to these enhancements, as he's considered to be one of the leading scientists in his discipline in the world. Our next presenter, Andrew Byrne. So Andrew is going to be taking us through the first of the enhancements, and Andrew has been with Angus Australia for the best part of a decade, and has been recently named the Genetic Evaluation Manager after a very long time as Breed Development and Extension Manager with us. He spent also considerable time with ABRI in core roles, including with SBTS. He's a wealth of knowledge and a strong contributor to the tools that Angus breeders have today to be making those informed breeding decisions. So we look forward to getting stuck into our first enhancement.
So the most significant enhancement that will be implemented into the TransTasman Angus Cattle Evaluation this December, and one of the most significant and important updates which has been made to the genetic evaluation in recent years, is the updating of all the variance components which are modelled in the main multi-trait component of the TransTasman analysis. And that really involves the variance components which underpin the calculation of all the EBVs, with the exception of calving ease, docility, and the two structural soundness EBVs being claw set and foot angle. So what we're going to do in this presentation is just go through and explain to you what those variance components are, what the variance components are that have changed, and also then what the effect on the breeding values of animals that we see published out of the analysis. So let's get underway. Let's start to consider about, well, what are the variance components? I suspect that's terminology which most Angus breeders don't use when they're sitting around talking about the breeding of their cattle. So if we explain those, some of the terminology which you might be more familiar with, if we start to think about what the variance components are really they're the ingredients, if you like, which underpin the calculation of the EBVs, or the estimated breeding values in the evaluation. And they include things like the adjustment factors, the heritability of different traits, and the genetic correlation that is modelled between the different traits within the evaluation. So we'll go through and just explore each of those in a little bit more detail. So the first variance component, if you like, the adjustment factors. And that really is when we have performance information, one of the first things before that information is analysed within the evaluation is that we have some pre-adjustments made to that performance measurement or that phenotype to take account of non-genetic differences in things like the age of animals at the date of measurement, the age of their mother, and also, in the case of some of the carcass traits, differences in the carcass weight of the animal. And we have different adjustment factors, if you like, or different adjustments that are made for animals of different sex, and also for animals born in different calving seasons, so particularly the autumn and the spring calving seasons. And those adjustment factors, which are specific, are really tailored to be most accurate for those different subsets of animals and born in different seasons. We also have different adjustment methods by the different traits. So for some traits, the adjustment which is made will be a linear adjustment. For others, it might be multiplicative, or for others, it might be quadratic. It's just whatever adjustment is most appropriate for the different trait and the different performance measurement in which we're analysing. And to give you what that might look like in practice, if we look at these two images on the screen, if the image on the left is just the raw performance of animals, we know that generally as animals get older, they get heavier. So we have that graph there of showing animals as age increases, so does weight. For the pre-adjustment, what we're trying to do is really remove the effect of the differences in age. So if we have a group of animals, contemporary group of animals, which are all weighed on the same day, and they have obviously differences in age within that group of animals, trying to account and remove the effect of those animals, like it is on the image on the right, where we basically have the same weight independent of age, and then that performance is then analysed within the genetic evaluation. So the pre-adjustments are really important in trying to remove those non-genetic effects and taking account of those so they're not reflected in the breeding values. The next variance component, which is modelled, is the heritability of traits. So people may have heard that term before, and really it's just talking about the proportion of variation in performance within a contemporary group that is due to the additive genetic variance or due to genetic differences versus other non-genetic type effects. Now, the heritability, which is modelled within the TransTasman analysis, differs by trait. And generally, I suppose, as we take a trait and we increase the heritability, what kind of things do we see? It means if we've got a higher heritability, then the individual's own performance will make more contribution to that animal's EBV by comparison to the performance of relatives. And that because more of the difference that we see between that animal's performance and the performance of relatives is attributed due to genetics. We also see that direct measures for the trait make more contribution to the calculation of the EBV than the measures for other correlated traits. And that's really important in things if we start thinking about our carcass EBVs and how they're kind of published. So they're published as differences at an abattoir endpoint, being the endpoint which is important within the commercial production system. So we look at what information feeds into those, whether it's a relative contribution of the direct measures of those traits, be it abattoir carcass measurements or scan data. If the abattoir traits have a higher heritability, then they will make more contribution to those breeding values relative to, say, the scan traits. Likewise, if it's a lower heritability, then the scan traits would make, and depending on the correlation, but would make a relatively higher contribution to those EBVs. Also, traits with a higher heritability will have a higher accuracy value, so a higher EBV accuracy value next to them, all other things being equal. And importantly, the heritability also has quite a big impact on the spread that we see in the EBVs. So we've got the same, difference in performance measurements. The more of that difference, which is attributed to genetics, the more spread that we see in the EBVs, or more difference that we see in the EBVs between animals. The last variance components, which are relevant in this kind of context, are the genetic correlations between traits. So that's really just the genetic relationship that exists between the traits and how that's modelled in the genetic evaluation. And really a way of considering that is if we just change the genetics for one particular trait through selection, then what kind of change would we expect to see in other traits just due to that genetic relationship? So if we just made selection for 400-day weight, what change might occur in other traits like 600-day weight or carcass weight or even birth weight due to that genetic correlation. And the higher the genetic correlation between traits, I guess the more information on that correlated trait will contribute to the EBV by comparison to the direct measurement of that trait. And that's really particularly important. The genetic correlations which are modelled within the evaluation are really important when we have traits which we don't routinely measure. So for a trait like retail beef yield, where we don't routinely get phenotypes on animals where they're in the abattoir and they're boned out to measure the amount of saleable meat out of that carcass, it really does rely heavily, those EBVs which are published for retail beef yield, on the genetic correlations which are modelled within the genetic evaluation. Now, the variance components, being those three components, the adjustment factors, the heritability, and the genetic correlations between traits. Importantly, the ones that are modelled within the TransTasman Angus Cattle Evaluation are specific for Angus cattle. So they're estimated based on all the performance information which has been contributed to both Angus Australia and also Angus New Zealand. So that the variance components, that is analysis of that performance information, and the adjustment factors and the heritabilities and the correlations which are modelled are specific and the most appropriate for that performance information which is being analysed in the TransTasman analysis. And in that way, the ones that we model in the TransTasman Angus evaluation will be different to what's modelled in other genetic evaluations for other breeds. So different to what's modelled in the Hereford analysis, different in the Brahman, different in the Wagyu, etc., with the variance components in each of those evaluations being appropriate and basically estimated off that specific breed's data. Now, the variance components in which we model are not updated every analysis or every year, but rather they're periodically updated from time to time. So the variance components which were used in the current analysis were last updated in April 2014, so about 8 years ago, and that was when they were implemented, and that was actually off a data set from May 2012 is where the research was done to calculate the variance components in which we use. So it's been 10 years, and as such, it's very timely that we go through and update and review those variance components. So over the last 2 years, it's really been a very long project and a very comprehensive project. It's been conducted by the Animal Genetics and Breeding Unit, or AGBU, in Armidale, to go through and review all those variance components and re-estimate them so that we can update them in our genetic evaluation. And I really want to take this opportunity to pay tribute to the scientists at AGBU, in particular Dr. Gilbert J. Rubin, who's undertaken and led most of this research, but also some of his colleagues which have played a pretty active role in terms of Dr. Steve Miller, Dr. Andrew Swan, Dr. David Johnson, Dr. Brad Wormsley, and also Dr. Natalie Connors, who have all met with us monthly over the last 2 years as we've worked through this project, alongside our colleagues at the Agriculture Business Research Institute in Armidale as well, or ABRI, who are the commercial providers of the genetic evaluation. And in particular, Dr. Brad Crook, who's been an active participant in this work. So it's been a large research project, a very important research project to go through and update those variance components. And it's really important to make sure that we go through and ensure that those breeding values that we're calculating on Angus animals are the most appropriate or the best estimate of the genetic merit of those animals for each particular trait. Now, alongside the re-estimation of the variance components, there has been will also be some changes, I suppose, made to the way in which some performance information is analysed or modelled within the genetic evaluation. In particular, there'll no longer be a pre-adjustment of the retail beef yield phenotypes which are collected for carcass weight. And likewise, there's been quite a major change to how the MSA marbling score data, coming out of the abattoir carcass data, how that is actually utilised within the evaluation. So previously, the MSA marble score data was just converted into an intramuscular fat measurement and then analysed as intramuscular fat within the analysis, alongside any of the intramuscular fat measurements which have been collected through the meat science lab on carcasses. Now that's been changed to a far more appropriate model, where now the MSA marble score is analysed as a particular trait within the analysis. We won't publish a breeding value, but it's still modelled as a correlated trait, if you like, and then contributes to the IMF EBV through that genetic correlation. When we start looking at the importance of updating the variance components, one thing to really note, and I'll show on the slide here with this table, is the amount of information which is available on which the variance components can be estimated. Now, for a lot of our traits, and in particular, say our weight traits and our scan traits, back in April 2014, there was already a lot of data recorded, and there is a lot more data now, but we already had a pretty good data set before on which to calculate those variance components. The key advantage this time, and the key step forward, is that the amount of information available for the abattoir carcass traits and also for net feed intake is significantly higher. So we can now estimate those variance components with far more rigour and ensure that we're actually utilising those phenotypes, or those performance measurements that are taken on abattoir carcasses and also in our research trials for net feed intake, can analyse that performance far more appropriately and therefore make sure we're utilising it in the best possible manner within the genetic evaluation. And so this time I really just want to take time to reflect, I guess, on some of the foresight of both our predecessor here at Angus Australia in Dr. Peter Parnell, but also the directors of the Angus Australia board at the time, back in 2010 when the Angus sire benchmarking program was established. So the Angus sire benchmarking program had a couple of objectives, and we will have seen the benefits in terms of progeny testing modern bulls, also building a comprehensive genomic reference population. But the third objective was really to generate data for the validation and refinement of the TransTasman analysis. And it's only now that we're really seeing that come into kind of effect, when we've now got this great data set for those hard to measure traits in which we can estimate those variance components and really improve the estimate of the breeding values that have been published on animals in the TransTasman Angus Cattle Evaluation. So it's provided an invaluable data set for those hard to measure traits. And if I show you what that means on the slide, if we look at, say, the amount of dressed carcass weight performance information that we have on animals within the genetic evaluation by observation year, you can see that there was some information coming in kind of in the 1990s and 2000s. But since the Angus sire benchmarking has kicked in, we've now got really good quality data and a lot more data than what we previously had before. And that's even further highlighted with retail beef yield. So retail beef yield, when we take carcasses in the abattoir and we break them down and actually measure the amount of saleable meat that we have out of that dressed carcass compared to, say, waste, you can see that the amount of data that was available, there's some data collected in the beef CRC in the kind of mid-1990s. There was a little bit of data collected in different research trials, but effectively not much of consequence through the 2000s. But now through the Angus sire benchmarking program, and in particular a collaborative project with the New South Wales Department of Primary Industries, we've now got, for the first time in a long time, a really good sizable data set of retail beef yield data on which we can estimate these variance components. And that's only been possible through the Angus sire benchmarking program. So just to reflect for a minute here and just look at what the take-home messages are so far. So importantly, the major update which will be made to the genetic evaluation in December this year is the updating of all the variance components in the main multi-trait component of the analysis. And those variance components being the adjustment factors, the heritabilities and the genetic correlations are really the key ingredients in the EBV calculation. Those variance components were last updated in April 2014. But now it's considerably more data available, and so we've got that, can now utilise that additional data to update those variance components and improve the manner in which we're utilising all the performance information in the calculation of breeding values. So what changes? So if we move on now to what changes, all the variance components have been re-estimated. What are the major differences? And if we start just at a very broad level, really we could say there's been minimal changes in the variance components which have been estimated for the weight traits, for the scan data, and also for the fertility traits. So as I mentioned before, there was quite a lot of data available for those before, and even though we've got significantly more data now, really we're coming up with a pretty similar estimate and not much changes within the genetic evaluation. The major change is how we're utilising abattoir carcass data and also how we're utilising net feed intake data within the evaluation. And within the different variance components, the major changes are really to the adjustment factors and to the trait heritabilities. The actual genetic correlation between traits is pretty well unchanged. So again, we'll go through now and explore that in a little bit more detail. So if we look at the adjustment factors first, and on this screen here, we've just got 4 different graphs reflecting the adjustment factors which are utilised for the abattoir carcass traits. And on each of those graphs, we have 3 different lines. So the blue line, first of all, is just the raw performance information. So if you like, for IMF and rib and rump fat, we could see there that, you know, as a carcass gets heavier, then we got an increase in either the amount of fat or the amount of IMF within the carcass. So it's important then also for carcass weight, you can see as animals got older, the carcass weight increased. So it's important as part of that pre-adjustment that we try and remove as much of the effects of the differences that we see in the performance for those different traits that are due to differences simply in carcass weight or are due to differences in the age of the animal on the day of kill. So the red line on that graph then is basically the phenotype after the adjustment has been made based on the current analysis. And then the green line is actually with the new adjustment. And you can see before, while the adjustment was attempting to remove the effect of differences in carcass weight or differences in age, it wasn't actually going the full way. So it was removing some of the effect, but not all of the effect. But now with the green line, which is far more horizontal, if you like, so it's removing far more effect of differences in carcass weight and age, in the case of the carcass weight EBV, and therefore those EBVs will be utilising that performance information, honing in in a far better way, honing in on the actual genetics of those animals for each particular trait. If we look at the heritabilities, so we go through, if we start looking again for kind of birth and growth and scan traits, not really much change. There's a little bit of kind of modification, if you like, and if anything, there's been an increase in the heritability of some of those traits, but the kind of changes are all pretty marginal, and the heritabilities which will be modelled in the genetic evaluation going forward for those traits are pretty similar to what we have been doing traditionally. The major changes actually start to occur over on the right-hand side of the graph here. So first of all, if I just note on days to calving, so days to calving already had a very low heritability, now has an even lower heritability. And the kind of effect we see on breeding values is that means that the spread, particularly in the EBVs, will shrink a little bit, so there won't be as much variation. And then that flows through to the actual selection index values, which are calculated for animals. The biggest change by far, however, is in the carcass traits. So we now have, for some traits, a considerable increase in the heritability. And then for traits like rib fats and also retail beef yield, we also have a significant decrease in the heritability. And that therefore really does impact on how that abattoir carcass information is analysed in the analysis, and then that flows through into the EBVs and then onto the selection index values for animals. Likewise, for net feed intake, we do see a slight decrease in the heritability of those different traits. So again, I guess the take-home message across all of that is similar to the adjustment factors, we have very similar kind of estimates of these variance components for the weight, scan and fertility traits in the case of scrotal circumference, but the major variation starts to occur in the carcass, the feed efficiency, and in this case the days to calving EBV. Lastly, just the genetic correlations. This just gives you an indication, I suppose, of the genetic correlations between traits for the carcass traits. And as you'll see, as you work down the kind of graphics on the screen there with the old correlations on the left-hand side and the new correlations on the right-hand side, there's some subtle changes as we move, and some traits might move from a negative 0.05 correlation to a positive 0.05 correlation. But realistically, there's not really much change in those genetic correlations, and those kind of changes will have pretty minimal impacts on the EBVs which are calculated in the evaluation. So if we move from the variance components and what's changed to, well, what does that then flow on to the EBVs? And a similar kind of story, and hopefully starting to see a bit of a theme now, is that with the updates to the variance components, we see pretty minimal changes in the breeding values, which are calculated for the birth traits, for the weight traits, and for the scrotal size EBVs. The major change, and it is a considerable change and a bigger change than what we've seen in breeding values for some time, are to the carcass EBVs, the net feed intake EBV, and also to the days to calving EBV. We also do see that flow through to selection indexes. So not only will the EBVs change for animals, but we'll also see changes in the selection indexes based on the correlated effect, if you like, or the flow-on effect from the change in the EBVs. We also see quite significant differences in the EBV accuracies which are published. So particularly due to things like changes in that heritability, that really then does reflect the actual EBV accuracy which is published alongside each EBV. So if we delve into that in a little bit more detail, this table on the screen here just starts to show you the kind of change that we might expect to see at a population level in two different groups of animals. So on the left-hand side, we have here the young bulls, and I think they're 2020 born male calves, so they're 2-year-old kind of male calves. And we have sires, so sires that they've got some more accuracy in their breeding values. And there are two different types of statistics provided here. First of all, the correlation, and the correlation really reflects the re-ranking that we see in how animals sit on those different EBVs. And for those of you that might be familiar with correlations can kind of range from +1. If it's +1, then everything is ranked exactly the same as it was before. If it was -1, then it'd be in completely the opposite direction. And a correlation of 0 is, by definition, there's no relationship between how animals rank on the previous and the new set of EBVs. So the first thing you'll see if you look down those columns is the general alignment of the EBVs. The correlations are all close to 1. They're all kind of above 0.85. So there's general alignment. But for some particular traits, there is a significant re-ranking. And the other variable, which I missed talking about, is the regression. So the regression, therefore, goes through and really reflects what the slope of the line is, if you like, when you compare the old and the new, and really gives us an indication of what the change in the spread or the variation that we see between animals in their EBVs. So they might still have a correlation of 1 and rank in the same manner, but the variation between EBVs can be significantly higher or less. So again, if we start to work down our kind of general correlations and general regression coefficients at a broad level, there's a general alignment, but there are some quite differences in the regression coefficient. If we look through the particular traits now in a bit more detail, as we've seen, and a common theme starting to work through, is there's really not much change in those breeding values for the kind of birth traits, for the weight traits, and interscrotal circumference. So for both the young bulls and the sires, we have a correlation close to 1, and pretty much a regression coefficient as 1 as well. So when they're a value of 1, pretty much ranking the same, similar kind of spread in EBVs. The big changes we see again are down towards the bottom when we get into the days to calving EBV, the carcass traits, into net feed intake, and then through to the selection indexes. So you'll see here, for the young bulls there, genetic correlations kind of down at that 0.95 kind of range. For the sires, they are slightly higher, so more at 0.97, 0.98. But significant differences in the regression coefficient. So when we start to see regression coefficients about 1.2, that means there's a lot more variation in the EBVs, and that reflects the increase in the heritability of those traits. Retail beef yield is one which is the reverse of that. So correlated with the reduction in the heritability of that trait, we have significant re-ranking, so 0.89, there's a lot of re-ranking. And those regression coefficients down at 0.53, really there's a lot of shrinking of the variation. So won't be nearly as much variation as retail beef yield EBVs as what we've seen before. And then as we flow down to net feed intake and the selection indexes, you'll see those correlations kind of between that 0.9 to 0.95 for the young bulls, kind of 0.96 to 0.98 for sires. and actually less variation in those index values, so a decrease in that regression coefficient. If we move from the population level to start to look at what that might look like on individual animals, and this is a horrible graphic, but one that does tell a story. This looks at the 50 most widely used bulls within the breed in the last 2 years, so those sires which are being used in the industry, and it looks at how much re-ranking they get in terms of their percentile value. So if they had a value on this chart of a 0, that would mean it is ranking in exactly the same percentile band as what it was before for that trait. So if it was at 20 before, it'll be at in the 20th percentile band moving forward. If it's a negative value, it means it's climbed up the percentiles a little bit. So if it was at negative 10, it will have moved up 10 percentiles bands. So if it was at the 20th percentile before, it'll now be in the 10th percentile. Likewise, if it had a value of plus 10, it's gone down the percentile bands by 10. So if it was in the 20th percentile before, it'll now be in the 30th. So a couple of take-home messages. First of all, you see that there is some pretty big re-ranking and changes in EBVs at an individual level, at an individual animal level. Next message I'd suggest is there's not much colour, if you like, on the left-hand side. So we start to look across again, the birth and the kind of weight traits. Animals are pretty well sitting exactly where they were before, but we get far more colour highlighted on the right-hand side. So we get far more re-ranking of animals, as we've talked about, in those carcass traits, in net feed intake, etc. And those changes can be quite significant in some cases. So while most animals will probably sit within the 10 or 20 percentile bands of where they were, there are some cases where they've moved as much as 50 percentile bands compared to where they sat before. So significant changes in what we expect to see in terms of those EBVs for those well-used sires. And that'll be reflected across the whole population at a kind of individual animal level. Now, one of the other things to note, I suppose, that is with the change in the EBV spread, we also see some changes in those EBV reference tables. So I've just got a example here for IMF, where again, if you note, I said the regression coefficient for IMF, I think, was around 1.2. So we got an increase in the spread. That really means when we start to look at that, animals which were in the top 1 percentile before had values of 4.6. They're now at kind of over 5. Likewise, at the bottom end, they were around 0. They're now down at close to -1. So we've seen a greater spread in those EBVs. And really that means that the people will need to go through and start to re-benchmark themselves as to what they think an acceptable EBV is in their breeding program. So if they had a particular value in mind, that now won't sit in the percentiles in exactly the same position. And so that you really need to go through and benchmark yourself by studying those percentile bands in a little bit more detail. It also means that even if an animal's rank hasn't changed, so effectively it was in the top 1 percentile before and for IMF, and it's still in the highest 1 percentile for IMF, its actual EBV value, the magnitude of it, will have changed. So if it was at 4.6 before and it's ranking exactly the same, it'll now be at 5.3. Likewise, if it was at the bottom end, it was previously at minus 0.1. If it was in the lowest 1 percentile, then it will now be at negative 0.7. So people, where animals sit and kind of the benchmarking with those percentiles will take a little bit of getting used to. Now, importantly, while we've talked about change, the obvious question is, well, is it change for the better? So we go through, we've re-estimated all these variance components, and I've told you it's very important, but does that actually then correlate through to the reliability, if you like, of those EBVs which are being published on Angus animals in the TransTasman Angus Cattle Evaluation? I'd really like to commend the scientists at AGBU, who again have gone through and not just done the parameter estimation, but have done some pretty solid validation of the EBVs, which will now be published in the new analysis, if you like. So they've conducted a range of different forward prediction analyses, and just to give you some idea of that, that really reflects what has been conducted is where we've got all the information in the current analysis. And AGBU have gone through and removed all the performance measurements on animals born from 2018 onwards and used those animals as a bit of a validation data set. So they've gone and calculated EBVs with all that information, that performance information removed, and then calculate the EBVs which are calculated on those animals in 2018 forward on the subsequent performance measurements of those animals. So really use that to validate, well, does the breeding value actually reflect the performance information what we see when those animals were measured in the population? So we have a graphic here which provides three different kind of criteria, if you like, for assessing the robustness of these EBVs or really validating those EBVs. So the first column is the prediction accuracy, and the prediction accuracy is reflecting how closely the performance information reflects the EBVs which are published, and generally, if you like, the higher values are indicating that it's doing a better job. It's got a higher prediction accuracy. And you can see down the board, those values are all quite high. When you start to see similar kind of validation statistics coming out of different genetic evaluations, both in Australia and also around the world and in different species, those prediction accuracies are very high. So values, particularly say for the growth traits at 0.8, we get down to the carcass traits at 0.6 to 0.7. They're doing a really good job of predicting breeding value of animals. There's also a bias value there's put there, which is just giving you an indication of whether there's any systematic bias in the EBVs which are calculated. And ideally, you want a value there of 0. And as you can see down the different traits, that bias is pretty close to 0 all the way down. And the third value is the kind of dispersion. So this is really giving us a reflection of whether the EBVs are over or under predicting the breeding value of animals. And you want, again, a value here of close to 1. And you can see generally down the board, we have values pretty close to 1. So there's been comprehensive validation done of the new information, and Angus breeders can really have confidence in those EBVs moving forward, that not only are we now utilising more up-to-date variance components, but the EBVs which are being published are doing a good job of predicting the breeding values of animals, and that's really been proven by some science at the Animal Genetics and Breeding Unit. So that kind of brings us to an end of this presentation. So just some take-home messages just to go back and reflect on kind of the conclusions from this presentation. First of all, the variance components in the analysis, in the main multi-trait component of the analysis, which includes all the EBVs except for calving ease, docility, and the 2 structural traits, have all been updated. And that has resulted in some considerable changes, particularly in the carcass EBVs, the feed efficiency or net feed intake EBVs, and the calving EBV, and that's flowed through the selection index values. Those changes in those breeding values are twofold. They're both re-ranking of animals and also the spread that we see, or the variation that we see in the EBVs. But importantly now, the EBVs which will be calculated in the TransTasman Angus Cattle Evaluation are utilising the performance information which is available in a more appropriate manner and are a better prediction of genetic merit than what they currently were before. And hence you can continue to use the EBVs with confidence in identifying animals within your breeding program which are most aligned with your breeding objective.
Okay, well, certainly a wealth of information there, Andrew, and we do thank you for your very in-depth presentation. We're just going to pause now for questions and discussions. While the questions filter in, and remember just to put them into the chat through your Zoom control options there. I think for myself, Jen, some of the take-homes, I think, particularly out of Dr. Steve Miller's presentation, was certainly that, we're very much focused on providing the most accurate information available to our breeders. And I think then hearing about those variance components, really, I think, changes may occur on individuals. And I think it would be a good suggestion that Andrew has to then reevaluate, percentiles and EBV values that breeders might have as part of their breeding program or whatever it might be. So there's a lot to get through there. Is there any questions that have come through, Jen? I'm sure there's lots to think about. Some of that would be brand new for a lot of our people that have joined today. I might throw over to you, Jen, to handle the questions.
Thanks, Jake. And yeah, thank you so much for that, Andrew. I know from my perspective, it's just been super informative watching your presentations for the umpteenth time. So thank you so much for that. There's a few questions coming in. Dr. Alex Ball has a few. I think he's still typing though. David, I'll ask your question on your behalf. David's question is, are there likely to be additional changes to EBVs down the track, e.g. sequencing replaces arrays, that sort of thing? Andrew, are you right to answer that?
Yeah, sure. And thanks for your question, David. Look, I think it's whether it be from sequencing replacing arrays or other developments. The genetic evaluation is a continually evolving and incorporating the latest science. So yes, there will, I think, undoubtedly be ongoing changes to EBVs as the science gets better and that gets incorporated into the genetic evaluation. So, and we tend to make those changes on an annual basis, so that change is kind of managed in a less disruptive way. But yeah, it's a given that science will develop and we'll get more changes going forward. I should say more improvements is the key thing there, Jen.
Brilliant. David, I hope that answers your question. If it doesn't, just keep them coming. Laurie has a question. Given the new updates, presumably you can't compare EBVs over time.
Yeah, that's a fair point as well, Jen. So because there has also been some other changes which within the analysis, just in terms of the genetic base which is used. So that would mean, yes, that these EBVs really shouldn't be compared to or aren't comparable with those EBVs which were published previously. So it should only really be compared within the December analysis, and then moving forward, they can be compared across analyses, yes.
Brilliant. Thank you, Andrew. Thanks for your question, Laurie. Alex's question is, given that you now are producing an MSA marbling trait, which is the trait people are paid on, why is it not published as an RBV?
It's a good question, Alex, and one I'm sure we have discussed offline previously as well. So certainly, I guess now we will within the model, and the changes to those model means that there is marble score is actually modelled as a trait, as is shear force, which I haven't talked about. But so we do have some new traits in there for the carcass EBVs. At this stage, they're not published, but over the course of the next kind of 6 to 12 months, there'll be some discussions as to how we might utilise those and how we might best kind of adopt those and utilise those in Angus breeding programs. And publishing some of those things as research breeding value is certainly one of the things which I imagine may come down the track. But yeah, those discussions still need to be held.
Beautiful. I hope that answers your question, Alex. Megan has one. Why do you not use variance components from US animals, especially bull size, used in our breeding plan?
So I think the important thing here with the variance components is that we're using the variance components which are most appropriate to the performance information which is being analysed in the TransTasman Angus Cattle Evaluation. So that's why those variance components are estimated based off the performance data which is in the TransTasman analysis. So they're most appropriate for the TransTasman analysis and therefore more appropriate than what variance components might be that have been estimated from other populations and other performance recording programs.
Perfect. Thanks, Andrew. Here's one that I can answer. Sam has asked, just clarifying, are these in the current analysis? Sam, these will be released in December 2022, which is the TACE run conducted, I think it's on the 30th of November. So that's when these enhancements will go live as a part of our yearly annual enhancements that we do around that evaluation run date every year. Megan has
sorry, can I just interrupt, just to add to that? So there's the mid-November results will be released today. They've just come onto the database today, so they don't include any of these enhancements, but as you've correctly outlined there, the next analysis, which we'll release in the next 2 weeks, will include all these improvements.
Beauty, thank you. Megan has an additional question. Will the excluded values, calving ease, docility, claw, and angle set use previous values for calculation?
Correct. Yeah, so they'll utilise the variance components which were updated at those times. And the reason I suppose they haven't been updated this time is just due to the structure of our genetic evaluation, in that we have a couple of, I guess, sub-analyses. So we have our main multi-trait component, and then we have calving ease run as a separate analysis. and the structural traits are run as a separate analysis. So everything in the main multi-trait analysis has been updated. The calving ease variance components will remain as they were, and when that variance component estimation was last done, and likewise the structural traits are as when those variance components were done, which I think was in 2020 was the last time that they were done. So all those traits, yeah, the variance components remain as is in the current analysis.
Beautiful. Joanne has requested a standard deviation graph would be helpful. Andrew, is that included in the brochure that will be released to members?
It's not in the brochure as such, but certainly one of the bits of documentation that we'll need to update is the actual standard errors, if you like, that we have for each of the traits. So we have tables available now which give an indication, I suppose, of the potential change of each EBV at each different level of accuracy, and they'll be updated to reflect the new variance components. And as Joe and I've discussed numerous times, there's also turning that into an actual graph, which is available in some breeds, is kind of part of our development schedule with our software team. So won't be available in the short term still, but is certainly part of our future plans.
Joanne, if you're comfortable, what I might do is take your contact details. So when that's developed, I'll share it with you directly as it's of interest to you. We've got one other question. Everyone, if you've got anything burning a hole, just pop it in the chat and I'll ask. And has the updated heritabilities and genetic correlations been transferred into breed object 6 to re-estimate the indexes?
Yes, that's correct. So they have. So it's not only in the calculation of the EBVs, but we're now utilising the new variance components in the software, which calculates the selection index values. So within the breed object software, and that's will all be incorporated in the December analysis that's coming up.
They've elaborated and asked, Andrew, what is the correlation and regression coefficient of the AB index? Which is
so it was on the slide there for the $A. I think from memory, it's around 0.93 for sires, and the regression coefficient is actually slightly less. So again, from memory, I think it's around 0.9.
It's Andrew, I've got it here in front of me. It's the $A, it's 0.98 correlation for size, and the regression coefficient is 0.89. So correlation is reasonably high. There's a little bit of re-ranking, but the spread's a little bit less.
I think the younger sires had slightly less, younger bulls had slightly less correlation.
That's right. The bulls were 0.93 correlation, and the regression coefficient 0.82.
Does that answer the question? Good. Yeah, thanks. Megan has another question. I have found that older, heavier cows tend to have larger calves. Is there some adjustment made so that the birth weight is not unfairly adjusted up?
So I didn't talk about that within the presentation as such, but in terms of this specific example, but certainly there's pre-adjustment made of birth weights to account for differences in the age of dam, and so that adjustment has been updated and is pretty similar to exactly the adjustment which has been made for some time. Obviously, there's been a lot of birth weights recorded over time, so that adjustment now that's in the analysis is fairly robust. But we'll certainly account for that, and the fact that there's definitely, I suppose heifers have lighter calves, all other things being equal, but vice versa, you say older cows have heavier calves just due to the age of the female.
Perfect. That's all the questions we've had for now. Thanks, Jake. And thank you so much for that, Andrew. Just the amount of information that you have wandering around up in your head always fascinates me. So it's incredible that all of this just comes straight off the cuff for you. Jake, I think we're right to move on. And just a reminder that anyone who has any questions, just keep them coming through and we'll address them at our next break, even if it was applicable to this presentation.
Fantastic. Thanks, Jen, and thanks, Andrew and Christian. And totally agree. This is a perfect opportunity to ask those questions that you'd like answered that are relevant to to the presentation. Our next presentation comes from Dr. Andrew Swan, who you may or may not know, but Dr. Swan is a principal scientist at the AGBU in Armidale, and Andrew studied a Doctor of Philosophy, obviously through the University of New England, and particularly most of his studies has been around multi-breed evaluation procedures, so certainly an expert in his field. Andrew is also a member of AGBU's sheep research team and has focused a lot of his time and effort on developing genetic tools that have been rolled out to the Australian sheep industry very successfully. Andrew's also been one of the leaders in incorporating genomic information into ASBVs, or Australian sheep breeding values, and also developing the breeding objectives and selection indexes used in that part of the industry. So we very much look forward to Andrew's short presentation, and thank him for his time.
I'm Andrew Swan from the Animal Genetics and Breeding Unit, and I'm part of the team that develops the breed plan system used by the TransTasman Angus Cattle Evaluation. And as you all know, the primary outputs from TACE are EBVs and accuracies for individual animals. And in 2022, one of the important changes to the system will be the introduction of a new algorithm for calculating accuracies with genomics. Now, this has been made necessary by the growth in genotyping by Angus breeders. And just to give you an idea of the size of the task, the main TACE analysis consists of around 3 million animals in the pedigree, with 11 million trait records, 29 EBV traits, and more than 230,000 animals genotyped. So if you think back to your high school algebra, a simple analogy is that every time we do a TACE analysis, we are solving a set of 100 million simultaneous equations. Thanks to the modern computer hardware and software, it is entirely feasible to do this for EBVs, which are the exact solutions given the data going into the model. But calculating accuracies is much more difficult computationally and requires a degree of approximation and splitting the task into manageable pieces which are then combined. So when we introduced genomic evaluations 5 years ago, we developed our genomic accuracy algorithm at the animal level. This made sense when there were fewer animals genotyped than there were SNP markers. However, the problem now is that as the number of animals genotyped has increased, the computing requirements have grown exponentially to the extent that we are about to hit a ceiling where it will be no longer possible to provide accuracies. So the neat thing about our new algorithm is that it is framed at the SNP marker level, and because the number of markers stays relatively constant from year to year, the computing requirements are sustainable over time. With the new algorithm, you will see shifts in accuracy values for some animals, and the reasons for that are that while we've improved the algorithm, there were some aspects that we had to do differently. So some of the larger changes we observed were for traits with smaller reference populations, some maternal effect breeding values, and due to a correction we made to the calculation of genomic inbreeding, which is needed for accuracy. With this in mind, one of the things we often get feedback about from users is that accuracies don't change by very much when an animal is genotyped. Now, the reason for that is that if the accuracy from pedigree is already high, for example, if an animal was already measured for the trait, or especially if it has had progeny measured, adding the genotype only has a marginal impact on the accuracy. Importantly though, while accuracy might not change much if it is starting from a high base, you can still see changes in EBVs, although these are typically within the limits of expected changes. So our advice is that while accuracies are an important guide about the level of confidence you can place on the information contributing to EBVs, selection decisions on the EBVs themselves will be what drives genetic progress. Validation studies we've recently been doing using EBVs from TACE are showing that selecting amongst genotyped animals is substantially improving our ability to identify animals of the future. So in summary, the new accuracy algorithm will ensure the sustainability of TACE evaluations as the use of genomics continues to grow. Secondly, there will be changes in some individual accuracies due both to improvements in the algorithm and things we had to do differently. And finally, while individual accuracies are an important indicator of the level of confidence you can place on EBVs, it is the EBVs themselves that drive genetic progress.
Thanks, Andrew, for that short presentation. I think that one of the take-homes for me out of Dr. Swan's presentation there was really that the new algorithm is not expected to result in the changes of EBVs themselves, but more so in the EBV accuracies. And I think that's a key point, just to summarise there, that was very different to Andrew Burns' initial presentation. We're now going to hear from Andrew again, and this one is going to be in relation to enhancement number 3, we're calling it, but is really around the new software for docility EBV calculation.
So one of the enhancements which will be implemented this year is the introduction of new software for the calculation of docility EBVs. And explaining the new software, if we firstly just reflect on the previous software, or the software which has been used for some time now for the calculation of docility EBVs. Docility EBVs are actually calculated within a separate analysis within the architecture of the TransTasman Angus analysis. So they're in a single trait or a univariate analysis where docility is just analysed by itself. So in that way, only docility scores contribute to the calculation of docility EBVs, and there's no correlations modelled with any other traits. And as its own separate analysis, at the moment in the software, not all animals are included in that analysis. So animals are only included in the calculation of docility EBVs if they have docility scores, plus there's also 2 generations of pedigree. So essentially, to be included in the docility analysis, animals must have been scored for docility, have progeny scored for docility, or grand progeny scored for docility. Now, the new software which will be implemented this year is similar, if you like, in that it is still maintaining calculation of docility in its own separate univariate analysis. However, this time we now are including all animals from the main multi-trait component of the analysis in the calculation of docility EBVs. So all animals which are included in the TransTasman analysis will now go into the analysis which calculates the docility EBVs. And that has a number of advantages. So the first major advantage we have, is that we now get docility EBVs published for a lot more animals. So we go from, in the current animals, from around 25% of animals in the population which will have docility EBVs to over 90% of animals which will now have a docility EBVs published for them. And if we look at the image on the screen here, you can see that means in, say, 2021 born calves, we go from just over 18,500 animals with those EBVs published to over 76,000 animals with EBVs. Now what that'll mean, the other kind of consequences that we have here, is that we'll now start to see docility EBVs published for animals that haven't themselves been scored for docility, or possibly are in herds who have never gone through and actually collected docility scores. So in this scenario, all those EBVs are being calculated now based on the docility scores of relatives. So we might have a scenario where we've got animals that are by a really well-used sire that are in a herd that hasn't collected docility information. Previously, those animals weren't included in the analysis. Now they are, and the EBVs which will be published for them will be based on the kind of information that we know on that well-used sires and his progeny. Importantly, I suppose there's still a minimum accuracy threshold, so while we get EBVs for a lot more animals, animals will still only have that EBV published for docility if they're above the minimum threshold of 25% accuracy. Another change will be, with the changes to the docility software, is a change to the breed average EBV. So the breed average EBV for docility is around +7 at the moment, and that will increase up to around +20. And there's several reasons for that. One is the inclusion of more animals in the analysis, but there's also been some scaling of that EBV, or for those that are more technically minded, a base adjustment to increase the average or the magnitude of those values, just so that we don't get as many animals actually at the lower end of the population with negative EBVs being published. So what that will mean, and that the introduction of that is that breed average will move, as I said, back up to about +20. But for animals which have EBVs, we'll also see an increase in the magnitude of those EBVs. So if they had an EBV before of about +10, we'd expect their new EBV will be up around +25. Importantly, they'll still be in exactly the same rank, so if we look at our percentile band, that will be unchanged. There will also be some slight re-ranking for some animals with the changes to the docility software. So if we look at these two graphs, just showing you the kind of, for animals which have docility EBVs now, when we move to the new analysis, new software, the kind of re-ranking that we've got. So as you can see for bull calves, I think these are male calves born in 2020, which have a docility EBV now with a minimum accuracy of 60%, you can see a very high correlation, so very minimal re-ranking. Similarly on the sires, there that have existing EBVs, correlation's a little bit less, but still at 0.98. So we still have a little bit of re-ranking as more animals are included in the analysis, and that's due to really better linking of the pedigree information. So they'll be providing a better EBV, but there will be some changes for those sires. So I guess the take-home message out of this enhancement is that we will now have new software for docility. We'll get far more animals with docility EBVs being published, and that will in turn be providing the Angus industry in Australia and New Zealand with a better selection tool on which we can base our selections for docility. In association with our normal management of docility, in particular culling animals which have unacceptable temperament, we'll now have docility EBVs which we can also put as part of our selection decision to ultimately further improve the docility within the Angus breed. Thank you.
Thanks, Andrew. And certainly docility goes without saying, a very popular and important trait amongst many cattle breeders in Australia. So going to obviously be very much a point of interest. I think the 4 points for me, certainly, Andrew, that I took out of your presentation there is there will definitely be docility EBVs on more animals. I think that goes without saying. The docility EBVs published for animals without docility scores as well, which some people will find new. There's also going to be a new breed average EBV for docility, and there are also some other changes to the docility EBVs. So just a reminder, if you do have any questions, we will be pausing in another short while to go through any of those discussion points or points of clarification. But we now will move on to enhancement 4, which is the publication of leg angle EBVs.
One of the enhancements which will be implemented into the TransTasman Angus Cattle Evaluation this year is the introduction of a new EBV for leg angle. So leg angle will now be published on animals which are recorded with Angus Australia from December 2022 onwards. And the new leg angle EBV really provides estimates of genetic differences in animals in rear leg structure when viewed from the side. And it's very similar, if you like, for the old rear leg side view EBV that many people will be familiar with. And in this case, again, similar to our claw set and our foot angle EBVs which are published, the lower EBVs for new leg angle EBV are expected to produce progeny with, on average, a lower score for rear leg side view, which is reflecting those animals which are straighter basically through the hock joint or less sickle hocked. Now, if we look at this graphic here, which just shows the variation which we have in the new leg angle EBV. So here we just have sires with greater than 5 progeny, which have been scored for rear leg side view. And you see the EBV across the bottom. There's quite a lot of variation which we see, genetic variation, which is reflected in this breeding value. So at the lower end, we have animals there kind of with an EBV of kind of plus 0.5. Through to at the higher end, we have EBVs of kind of plus 1.5. So around a 1 score difference in breeding value, and therefore basically a half a score difference on average in what we expect to see in progeny from animals at one end to the other of that EBV percentile band. So those leg angle EBVs, just to delve into the technical nature of those in a little bit more detail, as many of you might expect, those EBVs have been calculated based on the subjective scores which are submitted for rear leg side view. And similar to claw set and foot angle, that includes scores which have been submitted by both accredited technician but also breeder assessed scores. The actual analytical model which we utilise for leg angle is again similar to claw set and foot angle, so it runs a linear model versus a threshold model in what it used to run with our old rear leg side view EBV. It is a single trait model, so that side of it is similar. It does still only include scores of 5 to 9, so similar to claw set and foot angle. It has only got those scores of 5 to 9. That doesn't result in the removal of many scores, so we only have a very low proportion of animals, I think around 4% of animals, which have been scored with a score of 4 or less. But there is research now that's been scheduled to go through and try and look at how those scores of 1 to 4 could be utilised within the analysis. It does also, importantly, this new leg angle EBV also incorporates genomics, and that provides major benefits to the actual prediction accuracy of the EBV. One difference to the claw set and the foot angle EBV of the new leg angle EBV is that we're only running an Angus Australia only analysis. So there are no scores or phenotypes which have been collected on animals in North America. And so this analysis is really only published on EBVs recorded with Angus Australia, and we can't directly compare to any EBVs in North America, which is different to the claw set and the foot angle EBV, where there is a direct comparison. Now, importantly, as part of the establishment of this new EBV, there has been some comprehensive validation done. So there's been some forward validation kind of analyses conducted using the LR method, which is a common method used within the animal genetics kind of space to kind of validate and assess the robustness of different breeding values. And really it just goes through and actually investigates how well the performance of progeny has been predicted by the breeding value. And again, there are three different measures of that robustness. We have our prediction accuracy, and you can see here a value of 0.57. So we are seeing that the EBVs are doing a good job of predicting progeny, future progeny performance. There's also a bias value, and ideally we want our bias values close to zero, and as this forward validation has kind of revealed. And there's also a dispersion value, which is giving us an indication of whether the breeding values are over or under predicting the true genetic merit of animals. And ideally we have a value of 1, and you can see here we have, for the new leg angle EBV in the forward validation that's been conducted, a value of 0.94, so very close to 1. So again, the forward validation here that's been conducted on the EBV has shown and validated the new leg angle EBVs, and so they can be used with confidence within Angus breeding programs. Now, just to finish up, I suppose there's a few notes to make about how we might utilise leg angle EBVs in selection. So just to reflect, the lower EBVs for leg angle do reflect progeny which are going to have a lower score, so therefore straighter angle, if you like, through the rear legs when viewed from the side. And really, when we're starting to look at what we're trying to achieve, what our breeding objective is in most Angus breeding programs, is that we're not necessarily trying to breed animals where we have a shift in the population, so through either to a higher score or a lower score, but really we're trying to reduce the number of animals which have got a score around that score of 5. So trying to increase, or conversely I suppose, increase the number of animals with a score of 5 or optimal leg structure when viewed from the side. So that then reflects how we need to utilise those EBVs in selection. So a good way to consider this is if we're culling animals in the lowest percentiles, if you like, so say the lowest 25% on the leg angle EBV, that's going to do a good job of enabling us to remove the number of animals which are kind of sickle-hocked from our breeding program. But we conversely need to take some care if we're going to start to select animals at the higher percentile bands, so or the lower EBVs. Make sure we're not shifting that population too far and actually getting ourselves too kind of post-legged or too straight through that hock. So really the message out of this is, I guess in terms of utilising the EBV, is first of all we need to select animals with leg EBVs which are appropriate for our breeding program, appropriate for the genetics of our animals. But in most cases that will involve just culling animals in the lower percentile bands rather than necessarily focusing on selecting those animals in the higher percentile bands. Thank you very much.
Thanks, Andrew. And I know a lot of our attendees today will certainly find the rear leg or the publication of leg angle EBV is certainly very handy for those that have including some rear leg structure objectives as part of their breeding program. And I think one of the important points there for me, Andrew, that you raised, it is an Angus Australia only analysis at this stage. So I think that was really well put together. And thanks for your time. We're going to move forward now to another presentation by Andrew. So Jen, you must have been right with that wealth of knowledge, because I'm not sure if he's drawn the short straw up, but certainly doing a great job of walking us through the enhancements we're about to see. come next month. So the next one we're going to walk through is the publication of Immunedex RBVs for genotype animals, and this is certainly one of the more newer RBVs or inclusions that we've had access to through some of the research and development that's been going on with our partners. So we thank Andrew for this presentation as well.
So the enhancement that will be introduced in December this year is the publication of Immunedex research breeding values for all genotyped animals. So for those that might not be all that familiar with the Immunedex RBVs, the Immunedex values provide estimates of genetic differences for an animal for overall immune response. And really under this, if we're looking at the breeding values, research breeding values, they range from a value of 0 through to a value of 100. And size with those higher Immunedex values, we would expect to produce progeny which kind of have enhanced ability to resist kind of disease challenges, so improved overall immune competence. And this is a really important breeding value, as we know over time, if we continue just to focus our selection on the traits associated with profitability, so improved growth rate, improved kind of carcass performance, that might have a negative effect on kind of the fitness traits that we expect to see. And we've seen that in other species. So they've done some research in this space over time where we've had a continual focus on production traits, having some unintended consequences on these kind of fitness or survivability traits. And that's expected the same in beef cattle. And we know from research which has been conducted by the CSIRO that we have a negative genetic correlation, if you like, between the growth traits and immune competence. So if we continue our focus on selection for those high productivity traits without monitoring selection for these fitness traits, we could have some unintended bad consequences. So it's important that these breeding values are starting to be developed so that we can balance that selection moving into the future. Now the Immunedex research breeding values are not like some of our other breeding values where breeders will go out and collect performance measurements for their animals, but rather they're a genomic breeding value. So breeders will collect a DNA sample on their animals and genotype that with either Angus GS or HC50K. And then based off a genomic reference population of animals, there will be an Immunedex value calculated for their animals. And that genomic reference population, which is principally animals in the Angus sire benchmarking program, where those animals have not only had a DNA profile collected, but they've also had performance measurements collected for two types of, immune response. So we have a cell-mediated immune response, which is tested, phenotyped, if you like, through a skin reaction test, and also an antibody-mediated immune response, which is collected through a blood test. So we have both arms of the immune system there that have got performance information collected, and that information combined with that DNA profile is used then to calculate the Immunedex values. So the change that we'll see in December this year is that previously only Immunedex research breeding values they were only available on sires in the Angus sire benchmarking program. From December this year onwards, they'll now be available on all the animals which are genotyped with Angus Australia. So you'll be able to access Immunedex RBVs for your animals by logging into Angus database search and clicking on the research breeding value tab, and those Immunedex breeding values will be available to you. Now it's important to note, I suppose, while those breeding values are available, they are still research breeding values, and while there's been quite a lot of research conducted and we're quite confident in the robustness of those breeding values, they are subject to a little bit more change and a little bit more validation, I suppose, as we move forward than, say, some of our more routine EBVs which are published in the TransTasman analysis. So people should take a little bit of caution when using those breeding values, understanding that they are still research breeding values.
Thanks, Andrew, and quite an exciting development there with the publication of Immunedex RBVs for all genotyped animals, and I think it's just another great example too of what value the ASBP really delivers the Angus breed over a long period of time now. So certainly a very interesting update, and we all look forward to seeing those enhancements roll out as well. One of our final enhancements to walk through this afternoon, ladies and gentlemen, is just a summary of changes to the genomic pipeline, and there's a couple of changes there that Andrew's going to present on. This will certainly be of some interest to some particular members, more so than others, but we certainly look forward to hearing about these updates as well.
So also a couple of other enhancements that are probably less significant enhancements, but really important to the overall maintenance of the TransTasman Angus Cattle Evaluation. So the first one is some maintenance of the genomic pipeline. So really that just refers to the pipeline in which genomic information feeds into the TransTasman Angus Cattle Evaluation and is used in the calculation of those EBVs. And there's three components to the maintenance of those. The first is that the reference haplotype library has been re-estimated. And for those that might not be all that familiar with how genotypes are used in the analysis, then the first step that is needed to kind of prepare those genotypes for inclusion in the analysis is a step called imputation. And that's where we take all the genotypes which have been collected on animals using a range of different kind of DNA chips and convert that into a standard genotype which can then be used for the calculation of breeding values. And that imputation process, or that conversion process if you like, uses and relies on a reference haplotype library, and that has just been re-estimated or updated based on all the genotypes which have been submitted over the last 12 months. The next update to the maintenance of the pipeline has just been an incorporation of additional SNPs, or single nucleotide polymorphisms. So it's really just taking account of some of the newer content which might now be available on our latest DNA chips and including that into the genetic evaluation. And lastly, the third component is a re-estimation of all the allele frequencies. So the allele frequencies are used as part of some of the quality assurance checks on the genotypes which are before they are included into the TransTasman analysis. And in particular, the checks that we use to just assess whether an animal is, I suppose, closely enough related to the genomic reference population for the use of that genomic profile in the calculation of their breeding values. So that they've been updated, and we might see some animals which were previously on that borderline as to whether they were closely related or enough. Some of them may now be included, versus some of them may now also fail that QA check and not be as closely related if they're sitting right on the borderline. So all those three changes, the maintenance of that genomic pipeline, they don't result in any really significant changes to the EBVs or the EBV accuracy values which are published. But nonetheless, they're still a very important part of maintaining this genetic evaluation to ensure we're producing the best possible breeding values. The other smaller change is just some changes to the importation of the overseas EPDs, or estimated progeny differences. So we import EPDs into the TransTasman Angus Cattle Evaluation for animals in North America, and that's particularly important where we get imported animals coming in which might have a lot of information available in North America but have very little information in Australia. So we import that EPD just as to provide some extra accuracy to those breeding values until such time as those imported genetics actually have been performance recorded and we have some information available in Australia and New Zealand. So the changes that we'll see this year is that the EPDs are updated quarterly, but in December this year, all the EPDs for animals which have been recorded with the American Angus Association and Canadian Angus Association will be updated as part of that routine kind of refreshing of those EPD information. One of the changes we'll see though, however, is the EPDs will no longer be updated for animals which are recorded with the American Red Angus Association. There's only a very small number of those which come in, but we're just not all that confident that we continue to bring those EPDs in and make sure that we're utilising those as appropriately as we should in the calculation of the breeding values. So the decision has been to stop doing that as of December this year.
Righto, thanks, Andrew. I think some of our members may well have certainly found the updates for the EPDs for those of us that are, also looking for genetics, particularly from the US, that are reasonably new stage, and also the changes for Red Angus too. So thank you for that update. We will now be pausing just for some more discussion and questions. So if there is any questions coming through, now is the perfect time before we move into our last segment. And we thank Andrew for the significant amount of time putting those presentations together. They're very comprehensive, and I would imagine that there will be a number of questions that should come forward based on that information. So Jen, I might throw over to you to handle the Q&A section, and I think we've got at least a couple there, do we?
Yeah, we've got one so far. As Jake said, yeah, keep those questions coming. If it's not relevant to the presentations that you've just seen, but relevant to some of the previous sessions, there's no wrong time to ask them, so please put them in. One question we have is, would it be possible to get the immune index in the expanded layout rather than looking at individual animals?
So thanks, Jen. Yeah, I probably didn't articulate exactly how the immune index RBVs would become available to people as well as I should have. So certainly, I'm not sure it's in the expanded layout, but it is certainly in the, if you change the layout to the research breeding values, then that would display it in those tables, and you can then go to the report center and download that as a CSV file, etc. So yeah, so you will be able to view it on an individual animal. It will certainly be available in those RBV layouts. I don't believe we put the RBVs in that expanded layout, but it's also something that could be considered if there was enough demand for that going forward.
Yeah, the other thing you could do, Andrew, is just customise your own layout. So you can actually add the RBV in a customised layout and save that. That's also a good option for members who want additional information that's not in the default tabs.
Perfect. And if you're looking for help as to how to do that, how to navigate Angus Tech and the Angus database search to be able to look at that, that's what Jake and I are here for. So if you have questions about how to see those in the way that in an expanded layout type format, yeah, just feel free to give us a ring. Joanne has asked, will feet and leg angle be included in dollar indices?
The short answer is no. So they're not currently included in the calculation of the indices. It's definitely something which into the future would be something that we would like to explore. The key challenge there is, first of all, I suppose, how we put a economic value on the trait. So for the calculation of the indexes, the fundamental manner in which they function is we need to come up with what the net economic benefit is of making change of 1 unit in each of those traits which are modelled in the analysis. So that's possible, but there would need to be some work done to, first of all, estimate what that net economic benefit is, and then that would also need to be incorporated into the software which we utilise for calculating those indexes. So there's more research and development that would be required to enable that, but certainly would be something that would be nice to do in the future.
Perfect. The work never ends. It's great. Sorry, did someone have something they wanted to add there? No. Sam has a question. Will a paper or book describing leg angle be available for on-farm decision making, similar to foot angle and claw set?
So just if I think I'm understanding the question properly that's come in, but certainly in the paddock guide, which was circulated in the middle of this year, I think, for the structural traits, includes leg angle alongside the claw set and foot angle. So that content should be in the existing resources which we currently have, and it's also included in all the collection guidelines. I guess the point of clarification is it's referred to as, I guess, the phenotype is collecting as rear leg side view, even though it's been published as a leg angle EBV, but it's certainly the same trait. So I hope that answers it, and I didn't misunderstand the question.
Andrew, could I just maybe ask you to elaborate too, just on that collection? Are we looking for breeders to collect both legs, or just the one, or is there a difference there?
So I guess it's very similar to claw set and foot angle, Jake, as we move forward. So be collecting the worst leg, if as such. So if there was, I think the first thing would be to do it probably from a consistent side in practice. But if there were differences, then the score would reflect the worst side.
We don't have any outstanding questions, and I hope for those who have asked questions that we have answered them adequately. Feel free to ask again if you haven't quite understood or don't feel like we've addressed it to your satisfaction. So please keep them coming. Yeah.
Jen, I might just ask a question myself, considering I've got the mic. But I think some of our members may also find some interest in the immune competence. What do you, this is crystal balling a bit, what do you think the future might look like for, potentially breeders to be able to collect information on that on farm and not be as reliant on the ASBP or a reference population for immune competence?
So I suppose I'll have a first crack at that, and then Christian may add in his comments. But I certainly see, in terms of the future of Immunedex, that it would remain a genomic breeding value. So I think we're moving now into one of the benefits of genomics, and to get the most utilisation out of that technology in the future is that we'll be able to have breeding values available and utilise those in our selection that we can't collect on farm routinely. So I think Immunedex will be that, and the reality going forward is that we will be relying on a reference population, and it's where having an ongoing kind of Angus sire benchmarking program or other ways of generating that reference information will be really important, but practically won't be a trait which breeders are collecting on farm, and there may well be other traits that come in into the future that are similar to that. That's just my thoughts. I don't know if Christian, you've got anything to add or...
Yeah, cover it well. Look, it's a standard phenotyping procedure that CSIRO has developed in Australia. So if there were individual breeders wanting to talk to CSIRO directly and get some phenotyping done, that would be an option. However, it's going to be a high cost trait, and I'd suggest people are better off relying on Angus Australia maintaining the reference for immune competence with our collaboration with CSIRO and using their genomic information on their animals to get that prediction. For the future, I think where it's more going to go is the further understanding how immune competence affects the outcome traits. BRD is a critical one we're looking at. That's been part of the recent research and current research with CSIRO. The outcomes of high responders on more resilience to BRD. Pink eye is also one we're thinking about, and any of those sort of diseases that are caused by multifactorial things. It's not just one specific thing causing one bacteria or one pathogen, I guess you would say. So that's more of the future for immune competence. But we're in a really good position, really unique position in Angus Australia to have this available, unique around the world. The only exception would be in some other livestock species or the dairy industry who have similar things. Yep. Thanks.
Fantastic. Thanks for that, guys. No more questions there, Jen. If there's not, we might move on, but...
Oh, we've got one that's just come in.
Okay, great.
We had a cow get BVDV and then one of her daughters. It's just the comment from Joe. Thanks, Joe. Yeah, and I think that that heritability, Christian, what's the heritability that's been established from Immunedex thus far? Oh, muted.
I think Joe's referring to pestivirus in this case, so that's a different. I think that's a different discussion. So I think compared to Immunedex, unless I'm interpreting it wrong, what I suggest is to Joe get in touch with us directly, and we'll have a discussion on that one offline, I suspect. Jen.
Perfect. Thanks, Christian.
All right.
Righto, Jake. No others.
Very good. No, thank you, Jen, and thanks Andrew and Christian for that time. That's fantastic. Provide a fair bit of clarification and further points, which is excellent. We're just going to move into sort of the back end of this presentation. I'm very conscious of people's time, but we do now just have a short summarising presentation from Christian Duff, and we'll also outline some of the things that are coming up next, which is a really important part to this whole rollout of the TACE enhancements. So thank you very much, Christian.
Would you like to know more or access further information on the 2022 TACE enhancements? The information presented today, plus additional resources, is available from the central web page on the Angus Australia website. This includes access to all sessions presented at this Angus Connect event. The sessions will also be available for Angus Australia's YouTube channel. For documented information, a comprehensive brochure outlining the enhancements has been sent to all Angus Australia members by direct email. Please check your email account to find this information. Additionally, this brochure will be emailed in hard copy form to all members who subscribe to Angus Australia's genetic evaluation services. Similar information will also be a feature in the upcoming Summer 2023 Angus Bulletin. Several focus group sessions to provide an overview of TACE enhancements are also scheduled over the next 2 months. This includes online sessions with affiliated breeder groups from the 17th to 24th of November, a session with the Angus Australia board on the 26th of November, a face-to-face workshop with industry service providers such as semen companies, genomic service providers and beef consultants on the 8th of December in Melbourne, and small online group sessions for interested members which will follow the release of the enhanced EBVs from the 12th to the 16th of December. Interest will be gauged through an expressions of interest process. Members and other Angus genetic enthusiasts should also feel free to contact Angus Australia for one-on-one discussion both pre and post-release of the enhanced TACE EBVs. The easiest option is to simply contact the Angus Australia office and you'll be put in contact with an Angus Australia staff member who can address your queries. You're also welcome to contact staff in Angus Australia's Genetic Improvement and Extension team directly, including me, Christian Duff, General Manager of Genetic Improvement, Andrew Byrne, Genetic Evaluation Manager, Jake Phillips, Extension Manager, Jen Peart, Northern Development Officer, or Nancy Crawshaw, Extension Officer. Given the significance of the TACE enhancements, we encourage you to keep informed through the resources and events provided and by contacting staff at Angus Australia. To conclude, this is a really exciting time for Angus genetics in Australia and New Zealand, as the enhancements outlined today will keep Angus breeders at the forefront of genetic evaluation technology and genetic improvement.
Thanks, Christian, and thanks everyone for joining us. Just one other point to clarify, Christian did mention that in the brochure outlining the TACE enhancements will be sent to members today via email. That will actually be occurring in the next couple of days, as well as with some other resources. And I would expect that you will probably receive that by the end of this week. So I just wanted to clarify that if it's not in your mailbox this afternoon, you haven't actually missed that, but it is on its way. That brings us to pretty much to the end of our official time here for the Angus Connect TACE enhancements rollout. So I'm
Jake,
sure.
I have one more question actually, if you don't mind me.
Absolutely, Jen, please. Yeah, go ahead.
Laurie has a question and they say, I might be missing something. The correlations between new and old EBVs are high, but many of the 50 most highly used sires shifted their percentile rankings. Is it just that some move up and others move down?
Yes, I don't think that is the case, Laura. I think if we had others moving up and others moving down, some moving up, some moving down, the correlation would reflect that. I think what it shows is when we've got a really large population of animals in the calculation, that correlation value, that there's general alignment, but there's still a fair bit of variation within it when you start digging down and looking at individual animal level, particularly say in that group of that subset of sires. So across the population, there's general alignment, but that still allows us to have a bit of re-ranking when we delve into a few individual animals.
Laurie, I hope that answers your question.
Any other questions there, Jen, that have come through?
No, none. But no, I just wanted to say a quick thank you to everyone for attending. And yeah, if you've got any further questions, don't hesitate to contact us.
Absolutely. And thanks for your time, Jen, Andrew and Christian. We very much do appreciate it. So just a reminder that the enhancements that we've been talking about today are planned to be come out in the TACE analysis, which is planned to be released on the 30th of November. And either prior to or after that, if you'd like more information, please contact us at Angus Australia. Visit the Angus Australia website. There's a central webpage which is certainly getting a lot of information and videos added to it as the days come closer to the rollout of this enhancement. But please, if you'd like to talk to any of us that have been presenting today, we'd only be too happy to be able to help. So if there's nothing else from any of the contributors today, we might park it there and thank everyone for their time. It's a valuable resource and we do sincerely appreciate your commitment to what we're doing. Thank you.